All right, welcome back, everyone. So now we're moving on to a different topic, and this is a topic that we've more or less been alluding to the entire time. It has to do with the concept of a random variable. And a random variable is surprisingly easy to grasp, and that's more or less the point of starting the videos. So I want to make sure that whenever you hear the word random variable, you don't shy away from engaging in the concept. So let's go ahead and get started. From the very beginning, we've recognized that most of statistics builds from the desire to answer a certain question or gain insight into a specific question. So an example could be the time it takes for a person to navigate away from a loading web page. So we all know that when a web page is loading, and it doesn't load right away, we may have a tendency to try again, maybe reload, maybe move to a different web page. So what I want to point out is if you're interested in understanding the time that it takes for a person to move away from a web page, in other words, how long would they wait, then this is our variable of interest. And because that's my variable of interest, I want to point out that previously we just called it variable. But now I'm going to call it a random variable because it's a quantitative value. So in other words, it's time. So first of all, it's quantitative. And because I have to measure it, that's continuous. In this section, what we're going to do is instead of saying the variable, we're going to go ahead and use a shorthand. And that shorthand is going to stay with us for the rest of the semester. We're going to go ahead and write it as a capital letter close to the end of the alphabet. So for example, X, and I'm going to go ahead and write that that equals the time it takes for a person to navigate away. Or in other words, the amount of time that they'll wait before they move on to a different web page. So it's clear that that was the variable of interest, but now we're going to call it a random variable. Notice it's the variable because it's the variable of interest. The randomness comes from the fact that I have no idea what it actually is until I observe it. So for me to determine what the time actually is, I need to observe it. And usually you observe it via a sample. So let's go ahead and take a look at another example. The number of times a person checks their phone within 1 hour. Again, they are very important traits. The number of times, so in other words, I'm going to count every time a person checks their phone. I would need to observe someone, and I'm going to emphasize that this is a quantitative variable. And because I'm counting, this will be discrete. Now, if I were trying to write this using variables, I would pick a capital letter towards the end of the alphabet, such as Y. So for example, Y would be equal to the number of times a person checks. So capital Y, the random variable, is the number of times that a person checks their phone within 1 hour. Again, very similar to what we were doing before, except before we just simply use the word variable, not random. This is random because I have no idea what this number could be until I actually observe it in a sample. So finally, let's go ahead and introduce the last two examples. The number of people who have taken a COVID-19 test in a group of 20 people. Here, my random variable would be, so again, I need a capital letter, so let's make it like Z, and that would be equal to the number of people who have tested in a group of 20. And then finally, the fourth example would be the weight for next week. Again, that would be a random variable, so we need a capital letter. Let's see, X, Y, Z. W would be your weight next week. Again, it's the variable of interest. All of these share a common trait in that they are quantitative variables. So a quantitative variable that you're interested in will be called a random variable. And these random variables could be discrete, which means that you count. So if, for example, we count to obtain the value, then you get what's called a discrete random variable, because the answer could be 0, could be 1, could be 2, could be 3, and so on until maybe, let's say, what do we say, 20 people? Maybe this is 20. Versus a continuous random variable. If you have a continuous random variable, then you got to measure using some kind of tool. So you're using, for example, a weight, or sorry, scale, or the time it takes, that would be some kind of like watch or timekeeping device. So when that happens, the values don't have to be whole values, they could be decimals. And so what I want to emphasize is that a random variable in the visual summaries, we created their distribution. So the distribution is essentially us trying to describe the random variable. And that's what I want to get to in before we wrap this video up. So let's go ahead and just, again, recall. A random variable is going to be the variable of interest that I'm interested in, whose value I do not know because the value is going to be determined by chance when I take a sample, right? So I got to do it by observation. Now, we've already mentioned that a random variable could be continuous or it could be discrete. Oh, that's backwards. So this one right here is continuous. Oh, wrong one again. This one right here is discrete, so we count. And the one on the right-hand side is when we measure, resulting in a continuous random variable. What we want to do is we want to say, can you describe the random variable? And it's actually much easier than it sounds. If you're given a random variable, let's say capital X, so we're going to be using X most of the time just because I guess it's hard to move on from X. And so we're going to go ahead and use it here. And so given a random variable, if you count it, you can go ahead and essentially take a sample and then describe it. So what we're going to go ahead and do is we're going to say that when you're given a random variable, you're going to want to describe the probability distribution. And that's going to be our focus on this video and the next one. So let's just go ahead and end by stating that there two conditions need to be met in order for you to have a probability distribution. And a probability distribution is going to be a table or it's going to be a graph. We're going to go ahead and create both in the next example. So a probability distribution is a table or a graph that's going to do two of the things. It's going to list all possible outcomes of the random variable. So in other words, it's going to give you a list of outcomes, and then it's going to give you a list of corresponding probabilities for those outcomes. So those are mentioned here. It's actually fairly simple. So let me go ahead and just emphasize notation, a word on notation. So let's go ahead and take a look at this notation here that we see. What I want to point out is that whenever you see P, you read it as probability. Big X, don't say big X, don't say capital X. You want to say random variable. Either describe it in words or just say random variable. And when you see an equals, use the word is, and then lowercase x is a specific value. So once you get used to this interpretation, in other words, talking statistics and speaking it properly, it is a lot easier to understand what these two conditions say. So let me just go ahead and give you an example. In my example here of number 2, random variable example number 2 here, I went ahead and said, let's suppose I'm interested in the number of times that a person checks their phone within 1 hour. And there I called it capital Y. So capital Y is the number of times that a person will check their phone. So let me go ahead and erase this. Let's call it capital Y. So we all know what capital Y represents. It represents the number of times that a person will check their phone. So when I go ahead and write capital Y is, let's say 3, this is an entire sentence. And the entire sentence is pretty simple. It's simply the number of times that a person checks their phone in 1 hour is 3. So don't say Y equals 3 because that's not very informative. We want to go ahead and use the full descriptor of the random variable. So we're going to go ahead and say the number of times. So one more time, this Y equals 3. You don't want to read it as Y equals 3. You want to get into the habit of reading it as the number of times that a person checks their phone within 1 hour is 3. So therefore, when I write P in front of it, that means the probability that the number of times that a person checks their phone within 1 hour is 3. I'm asking you for how often that occurs. So let's go ahead and see if we understand that. Then condition 1 would say for every possible little x. Notice how it's lowercase x. That means that it's a specific value. So in other words, it's a number. So lowercase letters, we're saying there's going to be some number associated to it. Capital letters, we're going to go ahead and write out the entire sentence or descriptor of what it is we're interested in. So we're basically saying that the probability for every random variable being some specific value is between 0 and 1. That just means that we have a valid probability. So condition number 1 is that you have a valid probability. Condition number 2, remember capital sigma refers to the word sum. So it says if I were to add all of the x values, if I were to add over all x values, the probability that my random variable is that specific given value, and you add over all potential values, then the sum has to be equal to 1. So the second condition, you can say the sum of all probabilities equals means is 1. And that is it. So in the next example, we're going to go ahead and build the distribution as well as verify that we have a distribution. So please join me for the next video and let me know if you have any questions.